Hi, students. Welcome back. Today we are going to talk about moles to particles. In our last video, we did grams to moles. Today we're going to go moles to particles. We're going to learn a little bit more about Avogadro's number. So, hey, looking starting right off. So, please copy this top part in. All right, we've got page 28, moles to particles, section 4.5. What is Avogadro's number and how many particles are in a mole? So, let's jump right off and get right into Avogadro's number. Avogadro's number is equal to 6.022 times 10 to the 23rd particles in 1 mole. And if you remember yesterday, we talked a little bit, or the last video, excuse me, we talked a little bit about a mole and we were trying to compare apples to apples, if you will, when we were talking about moles. And so this is one way we're counting that many particles. Now remember, this is a really, really large number, and we said moles were an amount of substance. So this is just another way to calculate an amount of substance. And now we're using, like, we can look at how many atoms or how many molecules or how many formula units we have, and we can compare that to other atoms, molecules, and formula units. So our equivalent statement that we're going to use today is 1 mole equals that 6.022 times 10 to the 23rd. And it is particles. That is our general term, particles. We will actually get into a little more detail right here below. So we're not actually ever going to label anything with the word particles. Instead, we'll have to look at what type of substance we have and we go from there. For instance, if we have an ionic compound, that's an ionic compound. Remember, an ionic compound is made up of a metal and a non-metal. If we have an ionic compound, our label that we put on it instead of particles would be formula units. Formula units. That's what we're talking about when we're talking about an ionic compound. So anytime we have an ionic compound, we're going to use the label formula units. Remember, covalent compounds are those two nonmetals. We will use the label molecules. And last but not least, if we have a single element such as iron or something like that, we will label that with atoms, which makes sense because a single element is made up of atoms. You guessed it. All right, so how do we do this? Again, we're going to use unit canceling, which is what we've done all along. It will never lead you astray, provided you do it right. But if we're going 2 moles from particles, we're going to divide by Avogadro's number, aka 6.02 times 10 to the 23rd. So that's if we're going 2 moles. If we're going 2 moles, we'll divide by Avogadro's number. That means if we're going 2 particles from moles, we are going to multiply by Avogadro's number. Now, we're going to talk a little bit also about how to type this in our calculator. We actually don't need our periodic table for this assignment. We just need a calculator, and we need kind of a scientific calculator so we can type this in correctly. So let's kind of see here. We have how many moles, we're looking for moles, are in 1.2 times 10 to the 24th molecules. Notice we have molecules, which tells us, ding, 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 this is a covalent compound. So this is another way that we can kind of get some information about what's going on. All right. So what we're always going to start with is we're going to start with what we underlined. In this case, it's that 1.2 times 10 to the 24th molecules. And we're looking for moles, so we're going to divide by Avogadro's number, which makes sense because 6.022 goes on the bottom. And then our label would be molecules because we're talking about a covalent compound. And on top, we're going to put 1 mole, which is where we're going to stop, and we have water there. All right. So if you note, molecules cancel, and we're ready to type this in our calculator. Here is where it gets a little bit challenging. We have to type it in our calculator. Here is how. We're going to take 1.2, then we're going to hit that E button or EE button, kind of whatever we're using there. Remember, it's the exponent 1 on TIs. It looks like the capital EE. And a lot of times it's right above. You have to hit second and then either the comma on my calculator, x to the minus 1, but it's usually right above the 7. So we've got 1.2e to the 24th. Then we're going to hit the divide sign. We're going to say 6.022, that e again to the 23rd. So please, everybody, take the time to type this in right now to make sure you're doing it correctly. All right, that way we don't have calculator errors, which would be really terrible. So 1.2 e to the 24th divided by 6.022 e to the 23rd. The answer you should come up with is 1.99269, and it just kind of goes on, right? And if we round to two decimals, we would say 1.99 moles, because remember that 2 tells us we stay. So 1.99 moles is how we do that. Please make sure you got that. Please make sure you don't have an E something behind it. If you have, maybe come check with Ms. Griffith before school or after school to kind of get some help on typing it in your calculator correctly. Okay, awesome. Let's do another one. This time we're also looking for moles. This time we have formula units. So what little alarm should be going off in your head? Oh, that's an ionic compound. Awesome. We have an ionic compound, which makes sense because it's got that Roman numeral there. So let's see if we can't do this one. We're going to start with that 4.76 times 10 to the 22nd. We've got formula units. All right. We're going to put 6.022 times 10 to the 23rd formula units on bottom. Remember that particles is just a replacement. We're going to either replace it with formula units, molecules, or atoms, depending on what type of compound we have. Then we're going to put 1 mole. In this case, that's that iron 2 chlorate that we've been working with for a while now. Formula units cancel. So let's type this in our calculator. Let's see if you can do this correctly. We've got 4.76 e to the 22 divided by 6.022 e to the 23rd. So 4.76 e to the 22 divided by 6.022 e to the 23rd. We're going to get less than 1 on this guy, so we're going to get 0.079, and that's going to be moles. Please make sure you got that. 0.079 moles. Let's try the last one. This is not as hard to type in, but we'll see what we got here. So this last one says if you're given 0.5 moles of water, how many molecules? We're looking for molecules. So this time we're going to multiply by Avogadro's number. So we're going to go 0.5 moles of H2O. We're going to put 1 mole of H2O on bottom. That way we get moles to cancel. And on top, we're going to put Avogadro's number, 6.022 e to the 23rd. And since we're talking about water, that label is molecules. It also tells us that in the problem. So we're going to take 0.5 times 6.022 e to the 23rd, and you should get 3.01 times 10 to the 23rd, and that is molecules. Awesome. See you next time.